Part A. Show that the probability that Katrin wins with her first shot is 0.8. So key piece of information from the question is that Rhiannon starts. So in order for Katrin to win with her first shot, and the winner is the first to hit the target, then we need Rhiannon to miss on her first go, but then Katrin to hit on her first go. So part A, we're looking for Rhiannon to miss, which I'm going to use R dash or R complement to represent, and then C to represent C hits. So the chance of R missing or Rhiannon missing is 0.7. The chance of Katrin hitting is 0.4, so we get 0.28. It was to show that, and that's where it comes from. A key point here again is that we have independent events. Successive shots are independent of each other, which in reality might not be true. So if you keep trying to hit a target, you might get better at it with time, and the probability of hitting should increase over time. But for this question, we can make that assumption, which means we can simply multiply these individual probabilities together. For part B, again, it's to show that this time Katrin winning with her second shot can be written in this form here, k times 0.28, and we need to take the value of k. So for Katrin to win with her second shot, remember Rhiannon goes first, so we need Rhiannon to miss, but then we need Katrin to miss on her first shot. We need Rhiannon to miss again, and we need Katrin to hit on her second go. So Rhiannon missing 0.7. I'm free to just multiply all these probabilities together because we're told successive shots are independent. The chance that C miss is 0.6. Rhiannon misses again, but this time Katrin hits on her second go. Now remembering what the question said, show it can be written in the form something times 0.28. And if we remember from part A, 0.7 times 0.4 gave us 0.28. So I'm going to write this as 0.7 times 0.6, which is 0.42. So that comes from the 0.7 times 0.6. And then that times the 0.28, which comes from the 0.7 times 0.4. In other words, k is 0.42. Part C starts with the word hence. So we're looking for how can we use what we've already worked out. It also tells us we're going to get an infinite geometric series. So a bit of pure maths in this question. Find the probability that Katrin wins. It doesn't say on which attempt. So how could she win? She could win on her first go, or her second go, or her third go, or her fourth go, etc. forever. There's no upper limit on this. So it's the probability winning on the first go plus the probability winning on the second go plus the probability winning on the third go, and so on forever. And that's where our infinite geometric series is going to come from. Because in theory, Rhiannon might miss every single time. So there's no maximum value on how many times it might take Katrin to win. So to win on her first go, we already worked that out in part A. Win on her second go, we worked it out in part B. And the question was trying to help us here. They told us to write it in the form k times 0.28, which I'm going to do now. Remember, k was 0.42. If we think about what it would be for her third go, so that would be both missing, 0.7 times 0.6, and again, both missing, so that happening twice. Remember that bit was k, so k times another k, so that's both miss, and then both miss again, but then for the 0.28, that's Rhiannon missing, but Katrin hitting. So that's the chance Katrin wins on her third go. We notice we have a common ratio here. And we've been told it's geometric as well. So we can see our common ratio is k. So common ratio is k. The first term of this geometric series is 0.28. And we want to add together every single term in this sum, because that gives us the probability of Caterham winning on any go. First, second, third, fourth, potentially up to infinity. So the sum to infinity is a over 1 minus r. So 0.28 over 1 minus 0.42, which you could write as a fraction, cancel down 14 over 29.